blacksmith shop in New Heritage Village at the Seiling Waterloo Region Museum. Today I'd like to show you some more of the tools and equipment used by the blacksmith, how they're used, and how they're made. Today I'm going to show you some simple punches and chisels, one of the first things that any blacksmith would need to learn when they were starting their apprenticeship. Punches and chisels are made in any number of styles, sizes, and varieties. They all have different uses and are quite often made for very specific jobs and kept around just in case that job might come up again. The most common punches are used for punching round holes in steel. You see these in any number of sizes. These will be driven through the metal and then driven to the other side to knock out a small plug to open the hole. Punches can be any shape and can make a hole of whatever shape you need, unlike a drill, which can generally only drill a round hole through a piece of steel. This one is long and rectangular and is made for opening up holes in a thicker piece of steel for making the eyes in a hammerhead. Some punches allow you to make decorative impressions on the surface of the steel, like this one, which has a pyramid shape, and this one which has an indented square. Some punches are tapered so that in addition to punching the hole through the steel, they can be pushed through it even further to stretch open that hole, and this is called a drift. Chisels also come in a wide range of sizes and styles. They're used for very different purposes. A chisel like this is a hot cut chisel. It's got a thinner, narrower profile, and this is used for cutting through a piece of steel. A cold cut chisel has a broader, stouter angle. This is used for cutting through steel while cold. It doesn't leave as clean as a cut, but it can be useful in a lot of different operations. Curved chisels, or gouges, can be useful for cutting off rounded edges on bars, or for making rounded impressions in surfaces. The tools I'm going to make today are going to be made out of this old coil spring. Tools like punches and chisels need to be made out of harder steels than the normal steel a blacksmith would work with, because they need to be hardened so that they can punch through the softer, mild steel. A tool steel like this, or a high carbon steel, can be useful in making these because they can be hardened and tempered so that they'll be tough, strong, durable, and hard, unlike the mild steel, which can be durable but won't be hard. The first thing I need to do is heat up a section of the spring so I can straighten it out, so I'll have something to start with that's easier to handle than this whole coil spring. Using bending forks help me hold the steel while I stretch it out straight. I don't need it to be perfectly straight, just enough that I can be able to cut a piece off later. Now that the piece is cut, I can begin to straighten it into a more regular bar. Now normally, I would quench this back end so I could hold onto it with my hands while I'm working the front end. With tool steel like this, if it gets quenched in the water, it'll harden too quickly and it may cause stress and damage on the inside. Because this is a piece of an old spring, I don't know how many times it's been compressed, so I don't know how much damage is already on the internal structure. So it's safer, and I'll get a better tool if I let it cool down in the air. First, I'll make the punch. I do this by bringing out the end of the bar to a rounded point. First by shaping it square, and then by making it an octagon, and then by hitting it all over until it's round. Because this is a tool steel, I can't work it as hot or as cold as I would with mild steel. If I did, it would be more likely to split and fracture or to burn out some of the carbon that allows it to get hard. I was able to get it fairly round just with the hammer, but just to make sure that it's nice and smooth, I'm going to clean it up with a rasp. This is called hot filing. In order to work effectively, the top surface of the punch needs to be as flat as possible, and the edges need to be as sharp as possible. So using the vise, I can file down the top to get a smooth, clean surface and nice, sharp edges. Now that it's been shaped, I'm going to cut it to length. This particular chisel, I'm going to cut to 6 inches. Now we'll shape the end of the punch for where the hammer is going to strike the tool when it's in use. By having a slightly tapered surface at the back, it will concentrate the force of my hammer blows through the center of the punch. It will also make it harder for small chips to come off the back end of the handle. When the punch starts mushrooming out over use, when it starts sort of being squashed down and becoming wider than it is thick, I'll simply take a file and remove that so I don't have splits and chips coming off it, which can be dangerous. I can test the hardness with a file. At the back here where it hasn't been hardened, the file can get into the steel and carve off small pieces. Where up at the front, it simply skates off, doing very, very little. You can even hear the difference. But the tip here is actually now too hard for what I want to use it for. So the next step is to temper it. I've heated the back of the chisel, and I'm going to let the heat from here creep up to the top. If I scrape the surface with a file, I can see a band of colors slowly creeping up, from a bluish to a purplish to a brown to a yellow. Once this yellow color has crept all the way up to the tip here, I'll quench it again so that it stays at that hardness. These yellow colors are due to some interesting chemistry within the steel, but they are a rough guide that's been traditionally used by blacksmiths to determine the degree of tempering or softening that goes into the steel. By heating it up again and allowing it to let this heat creep up slowly, I'm changing the internal structure of the steel just enough so I can make it hard but not too hard. The punch is now complete. As you can see, it's got a very round tip at the surface and nice sharp edges on the sides. To punch a hole in the steel, simply hammer through one side, turn your piece over, and hammer through the other side. So there we have our punch, the hole we've made, and this tiny plug that it knocked out. Next I'll make a chisel. The first steps are the same as the punch, but instead of bringing it out square then round, I will flatten this out to make a thin, narrow blade. As I thin it out, it's going to widen, so every so often I have to come down from the side to keep it an even thickness. As the blade gets thinner, it also cools off faster, not only because there's less material to hold the heat, but also because the anvil surface and the hammer face is sucking the heat out of it on contact. I'm trying to keep the blade as straight in line with the body of the chisel as I can, which will make it easier for the force of the hammer to be directed down the center. This will stop the chisel from veering off to one side or the other when it's being used. Now I'll use the hot cut to get a straight end of the blade. Now that the shape of the chisel has been roughed out, I'll use a file to smooth out the surface, clean up any last little details in the shape, and to establish an angle on the cutting surface. By giving a slightly flatter angle to the very tip of the blade, it's going to make it a little bit stronger, but still nice and sharp for cutting. Just like with the punch, I'm going to measure and cut this to length. Next, I'll taper the end. Instead of rounding the end of the taper, I've left it a little more square, which will make it easier to visually see how straight I am relative to the blade. The heat treatment is just like it is for the punch. This time I'm letting the residual heat creep up the chisel so I don't have to do it in two different processes. Most important thing when using a chisel on an anvil is to keep the tip of the chisel cool by dipping it in water so it doesn't absorb the heat from the steel you're working it on. It's also important to not go all the way through the piece on the anvil face, or the chisel could cut into the anvil surface. If you get a lot of cuts and marks on the anvil surface, they'll copy over like a stamp onto the bottom of whatever piece you're hitting it on. Because the angle of the chisel is so sharp, it can cut a very thin groove without deforming the piece of steel very much. If I want to use the chisel to cut a piece off, I can cut it most way on the anvil face and do the last head of the cut on the very edge of the anvil. That way the chisel never comes into contact with the anvil face, damaging the chisel or the anvil. So there we are, two new tools for the blacksmith shop. It started off as an old coil spring that might have been tossed away. We now have two good solid tools that should last a nice long while with proper care and use. Tongs are one of the simplest and most essential tools of the blacksmith's craft. They can be made in any number of sizes and styles, with different purposes, uses, and advantages. Some tongs are designed to hold one very specific size of material. Some tongs have a more multi-purpose or generic shape and can be used to hold different materials in different ways, different sizes, and different angles. There are many different ways to make tongs, but I'm going to make this pair out of a couple of pieces out of our scrap pile. One of them is about a 1/2 inch thick round, one of them is about 5/8 inch thick square. The round piece I'm using as the reins, so I'll start by marking it right in the middle while cold, so I have a mark that I'll be able to find once it's heated up in the forge. Now that it's hot, I can cut the two pieces, the two halves of the reins. cooling off the first piece until there's only a small amount of heat left at the end, and hammering it out to gain more mass at the bottom of the piece of steel. This process is called upsetting and will be repeated several times until there's sufficient mass at the end to create the joint where it will join the jaws of the tongs. Now that there's enough mass, I'll create a joint called a scarf. This shape will be where the two pieces join together when it's welded to the rings. It thins out towards the end so that the pieces can join neatly without cutting into each other, and the increased mass will mean that the pieces won't get too thin when they're connected. Now that the scarf's been completed, I'm going to stretch out the reins to make them longer and more comfortable. The tongs are wider than they are thick. That's because when you're using the tongs, they're only getting compression in this direction. So if they're thinner on this side, they'll be lighter, but they'll still be just as strong. I'm also going to take down the corners because that will make it smoother and more comfortable in my hand. Now, I only had to work that from one side because it's compressed by the face of the anvil on the opposite side that my hammer's hitting it. Here's the starting piece and the finished piece side by side. As you can see, it's now significantly longer, but it's roughly a finished shape. These last couple of inches have not been finished because we'll do more work on those once it's connected to the jaws. For this next step, I'll begin forming the jaws. First, on one side of the anvil, I'll hit it half on, half off to form a step. Then I'll turn it 90 degrees. To make another step that will be the boss. I'll turn it another 90 degrees. Third step where it will join the reins. Jaws, boss, reins. Now that the basic shape is established, I can hammer it to closer to its final shape. It's closer to its final shape, so now I can cut it off so it can be attached to the reins. I don't want my hammer to come right through to the blade, so for the last couple of hits, I'll be hitting just behind or just ahead, so my hammer never touches the blade itself. Just like with the tongs, I'm going to forge a scarf to join the two pieces. This is how the two pieces will join to be welded together. I'm applying borax, ordinary laundry borax, which will melt onto the surface and provide a barrier for oxygen. If too much oxygen gets at the weld, it'll form scale, this gray flaky stuff that's been flaking off while I've been working. That's basically an iron oxide that will form a barrier between the two pieces of steel so they won't be able to join together properly. The two pieces are placed together in the fire so they can be brought up to a welding heat at the same time. Both pieces have to be brought up to near the melting point of steel, about 1300 Celsius, so that as they're tapped together, the two surfaces will fuse to become one single bar of steel. This is called forge welding. The two pieces are now stuck together, but they're only very lightly joined. You're going to have to repeat this process a few times to make sure that they're united in a way that's solid. I'm using a much smaller hammer for this, because if you use too much force, you'll see a lot of sparks, which is all the molten metal flying away from the steel. I need that to stay in place, because that's what's going to fuse the two pieces together. So I'm using a lighter hammer with more gentle blows. Because these have to stay at such a high heat, I've only got a very short amount of time each time I take them out of the fire to work on them. That's all I can do before I heat them up again. Now that the pieces are united a little more solidly, I can switch back to the bigger hammer and go back to shaping. They're still not welded all the way, so I'm going to keep working at a very high heat. This process gets easier as you do it, because now that the two pieces are joined, they're sharing heat more evenly, so they can stay at the same temperature more readily. Now that the two pieces are fully united, I can shape it to the final dimensions for the first side of the tongs. You generally don't forge much at a low heat like this, but right now I'm just cleaning up the surface, so I don't need to worry about keeping it hot enough to bend it and really shape it and form it. Next, I have to punch a hole through the boss for the rivet to go through to join the two sides. I have a punch here, a round punch, which I'll knock through one side, then I'll turn it over and push it through the other side through the Pritchel hole on the anvil. If all goes well, we'll get a nice clean hole, and you should see that last little piece come shooting out the bottom here. Right here was the little plug that came out. This actually is faster than using a drill, and it wastes less material. Both sides of the tongs are now finished. Now they need a rivet to join them together. One of the great things about blacksmithing is there's so much you can do with recycled materials. This is our scrap pile here, and I could find just about anything in here to use to make the rivet. Steel is the most recycled material on the planet and has been for the last 4,000 years. That should do. I need some extra mass to make the head of the rivet, so just like I did before, I'm cooling off one small section of the steel so that I can upset it to get more mass. Now that there's enough mass, I can use a heading die to shape the rivet. After a little bit of fine tuning and a bit of measurement, I can cut the rivet to size. I'm going to do a last little bit of fitting. Just to make sure it's a good solid fit. Welding the head of the rivet onto the boss isn't strictly necessary, but I find it makes the tongs more stable and less likely to bind because only one side of the tongs will be able to rotate on the rivet. Now that the two sides are completed and the rivet's set, I can place the rivet, the one side over the other, and set the other side of the rivet. Now the set tongs are joined, but they're too stiff to operate. The last couple of steps with these tongs are the fine details, tuning them up, making sure that everything operates properly, lining them up. So I'll do that between the vise, the anvil, and by hand. As the tongs are heated, the steel expands, which helps loosen it up. So I can wiggle it back and forth, and then tap everything into position. I can also use my vise to make fine adjustments, like compressing the handles and then twisting to bring everything back into its proper alignment. There. The last step is sizing the tongs. I'm going to place this piece of steel that's 3/8 of an inch thick in between the jaws and gently tap them down so it can hold this size. I can squeeze the tongs together to make them in the right position for when I want to be able to apply pressure. And this way I know that everything will line up when the tongs are in use. One extra step is to apply the museum's touch mark. This is a small stamp with our logo on it that I can place on the arms of the reins of the tongs just to mark it. A blacksmith normally wouldn't touch mark something as simple as tongs, but we do it here because we don't want things that have been made in our shop to be mistaken for actual artifacts. As you can see, the tongs now comfortably hold the piece of steel that they were paired for. I could use this for making horseshoes or for all number of different projects and uses. And here's the completed tool. When I started, this was just a couple of pieces of scrap metal that might have been thrown away. But now they're a tool that could last, with proper care, for a couple of 100 years. So we hope you can come see us again here at the Blacksmith Shop in Doon Heritage Village at the Seiling Waterloo Region Museum. Thanks a lot for watching.